All right, so this is indicator 10.2, and if you're at home, go ahead and pause the video and copy down this first graph, your time in hours across the bottom, your distance in miles across the y-axis, and then once you've got that copied, go ahead and unpause the video, and then we are having Jackson riding a bike at a constant rate of 5 miles per hour for 2 hours. That's that first bullet point. Then he stops at a friend's house for 60 minutes. So our second bullet point is that he stops. And instead of writing 60 minutes, we write 1 hour because our graph is in hours. So we're just going to go ahead and convert everything to hours. And then it says our last bullet point is that he rides at a constant rate of 10 miles per hour for 3 hours. So 10 miles per hour for 3 hours. So basically what we've done is we've saved ourselves the time of copying down this whole long paragraph. We don't need to copy down that it's Jackson. We don't need to copy down that it's a constant rate as long as you know it in your head. Who cares that it's at a friend's house that he stopped at? Because for right now, I'm just graphing it. I'm not having to write a story, so I don't need to add details like the fact that he's at his friend's house. Those details are already there for us. So the bullet points just kind of save you some time, and it's going to help you graph it, okay? So let's take each section one at a time, and I'm going to kind of color code these. So my first section here in red is that it was a 2-hour block where he went 5 miles per hour. So the first thing I'm going to do is I'm going to block off 2 hours just to give myself kind of that mental idea of this is the section I'm working with right now. Now, yesterday when we did the walk, run, jog graphs, I said everybody's might look a little different because your run and my run might be a little different. But as long as on our graph, as long as that run was the steepest slope, it was fine. Here, they give us the speed and how long they went. So our graph should be exact. Everybody should be the same. So if you go 5 miles per hour. Remember, this is a distance graph, so I need to think about distance. If you can go 5 miles per hour constant and you go for 2 hours, what's the distance covered there? 10 miles, right? 5 miles per hour for 2 hours. I can get very specific with my distance. And because this is a distance graph, I want to, right? If I can. So 10 miles. So in my little red section there over 2 hours, I can actually get very specific about how high up my slope's going to go because it's going to reach up to 10 because I know that in that 2 hours, I know that Jackson rode 10 miles. So I'm going to be very specific with my slope. And so everybody's slope for one like this should be exact because everybody should go in 2 hours, should go 10 miles. Okay? Now, the next section is a stop, and it's for 1 hour. So the first thing I'm going to do is I'm going to block off an hour here. Okay, that's the section I'm working in. And in that hour, remember this is a distance graph, so I care about distance. In that hour, how much distance was covered? None, right? He was stopped. So he didn't go any distance. So in a distance graph, a stop just hovers as a flat line up at the same distance as before because he doesn't gain any or lose any distance. He just stays the same. Then our last section, okay, is 10 miles per hour for 3 hours. Well, again, right, they got very specific here. First, let's block off 3 hours. So from 3 more takes us out to the 6. So there's my blocking off of 3 hours. In that 3 hours, if I can, I need to get specific, and I can here because they tell me 10 miles per hour for 3 hours, how much distance was covered? 30 miles, good. So think about where I'm at. I'm at 10 miles from my start. I go 30 more, so that takes me up to the 40 mile an hour or 40 mile mark. So in the 3 hour block between hour 3 and hour 6, I travel 30 miles, but I don't go up to the 30 mark. Notice that, right? I don't go up to the 30 mark because that would mean my overall distance was only 30. I go up to the 40 mile mark because I had already gone 10 miles. So when I add 30 more to that, you're going to go up to the 40. Now, you always want to check these graphs, and it'll help you catch an error like I just kind of talked about. So if you look at your hours, just your hours of your graph, how many hours did your whole graph take you? 2 hours, then 1 hour, then 3 hours. That's a total of what? 6 hours. If my hours of my story equal 6, then my graph should end at 6, and it does. Now let's look at your distance. My total distance traveled was 10, then 0, then 30. My total distance traveled was 40, which means my graph should end up here at 40. If you will do this little check at the end, you will catch errors like accidentally making your last section just go up to 30 because it says they went 30 miles. If you will total up your total graph miles and then make sure that that's where you're ending, you'll help catch some errors that way. Okay? All right. So when they get specific in the explanation and they give you miles per hour on a distance graph, you need to calculate distance and then graph accordingly. If you're not given distance or miles per hour, if you're not given miles per hour or distance covered, then you just would do it based on the steepness of your slope. Okay? Any questions on that? All right. Sketch this graph really quick, and then we'll bullet point it out again. All right. So let's look at the paragraph. Again, we're not going to write the whole paragraph. We're going to do it in bullet points. Okay. So we've got Allie drives at a constant speed of 45 miles per hour for 2 hours. So our first bullet point is that, let's make it in black here. Our first bullet point is that she drives 45 mph, which is miles per hour, for 2 hours. And my graph's in hours, that's in hours, so I'm going to leave it there. Okay? Then she decreases her speed for a construction zone to 30 miles per hour. 30 miles per hour for 30 minutes. Well, again, right? My graph is in hours, 30 minutes is minutes, so I would convert this into 1/2 an hour. Okay? And then after the construction zone, Allie increases her speed to 50 miles per hour. So 50 miles per hour for 4.5 hours. Okay. Then Allie reaches, it should say her, not his. Allie reaches her house and stops. So then you've got a stop. Okay. No gradual increase or decrease here, just a bunch of hard stops and starts. So we start out at a 2-hour block, which is going to take us out to here. And in that 2-hour block, Allie maintains a 45 mile an hour rate. And this is speed. So I find 45 miles an hour on my speed axis. And she maintains it. So that's a flat line. Always put points at the beginning and end of your lines. Then her next block is a 1/2 hour. So I'm going to go halfway between 2 and 3. And that's right there. And in that hour, she drops down to what? Or 1/2 hour, sorry. She drops down to 30 miles an hour. and she maintains that for 30 minutes. And again, you don't want to leave these hovering lines, so I'm going to connect my 45-mile block to my 30-mile block with just a straight up and down line because there was no gradual slowdown. Then it says she bumps back up to 50, so I'm going to put a point up here at this 50. And again, right, there's no gradual, so I'm going to connect it with just a hard straight line. And she maintains that for 4.5 hours. So I'm going to give myself a stopping point real quick. So I'm going to go from 2.5 out 4.5 hours. That takes me all the way out here to the 7 mark. So for that 4.5 hour block, she maintains 50 miles per hour the entire time. So just a nice solid straight line maintaining that speed. And then it says when she gets home, she stops. No gradual, so we're just going to go a hard line down to our stop and put a point at our stop. And again, check your total time. 2 hours plus a half hour plus 4.5 hours equals 7 hours. Our graph stops at the 7, so we're good. Okay, we started at 45 miles an hour. We ended at a stop. Our graph starts up at 45 and it ends at 0, which on a speed graph is your stop. Okay, good there? All right, kind of quickly sketch this graph because I want to make sure we have time to do these last two, and they're both quick. So across the bottom, we've got time in minutes, 5, 10, 15, 20, 25, 30, 35. And up the side, we have speed, and it goes 10, 20, 30, 40, 50 miles per hour up the side. All right, let's look and see what we've got going on here. So I'm going to bullet point this out. I've got that Kelly increases her speed to 20 miles per hour in 5 minutes. Notice that's worded differently. So in this first section, she's increasing her speed to 20 miles per hour, and she does that in 5 minutes. Okay, that's different than just saying she's going 20 miles an hour. So that should tell us we're going to have that catty corner kind of angled line because that's a gradual increase. Then she maintains that speed. Well, what is that speed? What do you guys think? Yeah, 20 miles per hour because she just now got up to 20 miles per hour. And then it says she maintains that speed for 10 minutes. And then she gets 50 miles per hour. And she does that for 15 minutes. And then in 5 minutes, she slows, right? That's that gradual. So in 5 minutes, she slows. So we're going to get a gradual slowdown to a stop. And we do that in 5 minutes. And this is just, these little bullet points are just kind of my shorthand. And I use the arrows up and the arrows down to remind myself it's gradual. It's not just a hard start and stop. Okay? So the first section is 5 minutes. So I'm going to give myself a guide here of what 5 minutes looks like on this particular graph. And in that 5 minutes, right, she starts at 0 miles per hour. And in that 5 minutes, she increases to 20. So that's going to be angled because that's a gradual increase. It's not just a hard 20 mile an hour start. Then it says she maintains that speed. Well, that speed is 20 miles an hour for 10 minutes. So I'm going to give myself 10 more minutes out, which takes me out to the 15-minute mark. And she maintains 20 miles an hour. So that's a straight line on the 20. Then it says she just goes 50. Doesn't give me a gradual time of increase. So we're just going to bump right up to 50. Hard line, straight up. Okay. And how long does she maintain that? 15 minutes. So that means from 15 that I'm already at, another 15 takes me out to the 30. Right? And in that 15 minutes, she maintains 50 miles an hour. So it's a nice straight line at 50 miles per hour. And it doesn't say she just stops. It says in 5 minutes, she slows to a stop. So first I'm going to give myself this 5-minute mark here. And in that 5 minutes, she slows to a stop. Well, my point at a stop is going to be down at 0, but because it's a gradual slowdown, it's going to be an angled line. Cammie does not like angled lines. And again, check your time, right? If you add up your time, you got 5 and 10 is 15. Another 15 is 30. And then 5 on top of that is a total of 35 minutes. Does your graph end at 35 minutes? It does, so it checks out. And she starts at a stop. She ends at a stop. We start and stop at the 0 miles per hour, so we're good there. All right, one more quick one I want to run by because there's one like this on your homework. And if you don't get a chance to sketch this graph completely, I would go back and watch the video, because when the bell rings, if I'm not done, I'm going to keep talking. I'm going to keep recording, and you can go back and watch the last 3 minutes of the video to catch this, okay? But I'll try to get it done. I think we can in 2 minutes. It's pretty easy. A semi driver is loading his truck at the loading dock. Sorry, a semi truck leaves the loading dock, right? So this is our distance from the loading dock. Our starting point is the loading dock. He leaves the loading dock. He drives at a constant rate for 2 hours. So we're not told what rate. We're just told that it's constant. And he's driving for 2 hours, right? Then it says he takes 3 hours to unload and reload his trailer. So 3 hours. What's his movement there? Is he going anywhere? He stopped, right? If he's loading and unloading his trailer, he stopped. Then it says he returns back to the loading dock at the same rate. So how long does it take him to get back to the loading dock? 2 hours. So our time breaks here are 2 hours, then 3 hours on top of that, which takes us out to 5, then 2 hours on top of that, which takes us out to 7, right? Those are our time breaks. In the middle time where he's loading and unloading, right, we don't know how far he gets in that time. We just know that he's stopped. So we can put it anywhere. He stopped in that 3 hours. That's when he's unloading and loading. So his drive there is this, and his drive home is going to be the same because we've already blocked off that it's 2 hours and 2 hours. Okay? The distance he goes doesn't matter. You could have gone up here and said he went this far, and then you would have angled and angled down. As long as your time frames are blocked off right, because it doesn't give exact distances, you're good to just estimate, okay? All right, complete your assignment on Cammie, and make sure to hit submit and submit when you're done, and email me if you have any questions.